Welcome to the second session of 15 minutes question answering. So let's start. We need to read the 36th question. Which one of the following substitutions introduced by site-directed mutagenesis in a protein is expected to bring about the maximum change in the isoelectric point in the mutant protein compared to the wild type protein? Answer is C. Arginine to glutamate. That will introduce a site-directed mutagenesis in a protein expected to bring about the maximum change in the isoelectric point in the mutant protein compared to the wild type protein. And which statement about amino acids is correct? The answer is actually A. They always have at least one amino group and at least one carboxyl group. That's true. All other statements are wrong. In the formation of proteins, it is a condensation reaction that links the amino groups of one amino acid to the variable side chain of the adjacent amino acid. The variable side chain of all of the amino acids are highly negative and carry a charge at neutral pH. The peptide bond that links amino acids together in a protein is a type of ionic bond. It explains why proteins are unstable at high temperature. All other statements are wrong. Okay, only the first one is correct. The peptide bond has a backbone of atoms in which of the following sequence? Which sequence? C. C in the sense C, C and C. The peptide bond is D. D in the sense P, Q, R and S. All are correct. The partially double bonded, polar, planar and mostly trans in proteins. Okay. Then a Ramachandran plot, once again I'm going to read that. A peptide bond is a partially double bonded, polar, planar, mostly trans in proteins. And a Ramachandran plot describes for a particular amino acid the sterically permitted angles for rotation about 40 and A in the sense rotation about the C mu C beta bond. R and S are correct statements. R in the sense rotation about the NCH bond and S means rotation about the CH bond. Okay. Then next question. The property of resonance as applied to protein structure is responsible for which one? 41C. 41C, the planar nature of the peptide bond. Okay. Resonance, planar nature of the peptide bond. The peptide bond in protein is 42D. D in the sense planar and usually found in a trans configuration. Then which one of the following bonds in proteins has a partial double bond character? Which one? 43C. C in the sense CN. CN bonds in protein has a partial double bond character. And on a Ramachandran plot, the entries of hemoglobin would be clustered around 44D, the right-handed alpha helix conformation. Entries of hemoglobin would be clustered around the right-handed alpha helix conformation. In the following Ramachandran diagram, which type of secondary structure do the region marked X, Y and Z represent? X, Y and Z. The correct answer is actually 45C. C means X indicate beta sheet. Remember that X beta sheet. Y right-handed alpha helix, Y right-handed alpha helix, beta sheet right-handed alpha helix, Z left-handed alpha helix. Is that okay? Beta sheet Y4 right-handed alpha helix, left-handed alpha helix indicates Z. And which one of the following statements related to the Ramachandran plot is not true? Which one is not true? 46. A in the sense almost all peptide bonds in proteins are cis. That's not true. But all other statements are supposed to be true. So the restriction of psi and phi angles limits structure accessible to unfolded form of proteins. A configuration that has 90 degree and psi minus 90 degree is disallowed. Yeah, that's disallowed. That's correct. Then 3/4 of possible psi phi combination are excluded by their steric clashes. Yeah, that's right. And which should be the net charge at pH 1 on the tetrapeptide given? 47B, B plus 2. Then aspartame, the synthetic sweetener, is 48. Correct answer a dipeptide. The next for the pentapeptide given 49. Correct answer is A. In the sense number of charged groups at pH 7 is 4. Okay. Then now we are going to learn about some questions related to protein structure. So next section is about protein structure. We could see answers and also questions. Which question we are going to learn? First question. If there are 20 kinds of amino acids and they can be assembled in any order, then how many different proteins of 100 amino acids long can theoretically be produced? And the correct answer is B. 220 raised to 100. Then how many different pentapeptides are there that contain one residue each of these given amino acids? 120 actually. Then in 5 residue long peptide, each amino acid can adopt 3 conformations. The total number of conformations that the peptide can adopt is 243. And if one needs to use the natural 20 amino acid residues with no restrictions on number of times a given residue type can be used, what is the total number of possible tripeptide sequences? It's actually D. 8,000. Okay. Then enormous diversity of protein molecules is due to, what is the reason? Sequence of amino acids, not because of R group of amino acids, not because of peptide bonds, not because of amino group of amino acids, just because sequence of amino acids. And an alpha helix represents secondary structure of a protein. You know that secondary structure of a protein. Okay. Then the shape of the peptide backbone making alpha helix in proteins is shape of polypeptide backbone making alpha helix in proteins is right-handed spiral. Okay. Then hydrogen bonds in alpha helixes are D roughly parallel to the helix axis. Hydrogen bonds in alpha helix are roughly parallel to the helix axis. And then an alpha helix is made up of 78 amino acid residues. What will be the value of axial length and also length when polypeptide chain is fully extended respectively? 9. Answer is C. Okay. 117 angstrom, 281 angstrom. Then consider 3 polypeptides of 15 residues each. They adopt distinct conformations corresponding to right-handed alpha helix structure. left-handed alpha helical structure and single strand of all beta sheet structure. Considering the shortest distance between the first and the last residues as the length of the structure, which one of the following statements is true? Actually, the third one is true. Beta strand structure is longest. Which one of the following statements about protein secondary structure is correct? 11 correct answer is actually C. So beta turns often contain proline. That's a correct statement. All others are not correct. An alpha helix is primarily stabilized by ionic interactions between the side chains of an amino acid. That's wrong. Beta sheets exist only in antiparallel form. That's also wrong. Then an alpha helix can be composed of more than one polypeptide chain. That's also not true. 11 C. Okay, that's correct. And the formation of an alpha helix results in a dipole along the helix with a positive N terminus and a negative C terminus. What is the most likely explanation for this phenomenon? The formation of an alpha helix results in a dipole along the helix with a positive N terminus and a negative C terminus. What is the most likely explanation for this phenomenon? 12 answer is supposed to be C. The peptide carbonyl oxygens, that hydrogen bond with amide hydrogens point towards the C terminus. That's the reason. And the mirror images of a right-handed alpha helix with all L amino acids will appear as 13. Correct answer is found to be B. So B in the sense left-handed alpha helix with D amino acids. Right-handed alpha helix with L amino acids will show mirror image. That's mirror image will show B. Left-handed alpha helix with D amino acid. Just reverse that. Okay. The next, a 20 residue peptide composed of the sequence given forms a right-handed alpha helix in methanol. If every alternate L to ALA residue is replaced with DALU, the peptide will probably 14. Correct answer is actually D. No, I'm sorry. D. Yeah, that's right. D means not form a helix of any kind. And which of the following has a quaternary structure? Which one? For 15B. 15B in the sense for 15B hemoglobin. Yeah, hemoglobin has a quaternary structure with 4 subunits. So for a protein to have a quaternary structure, it must have 4 amino acids. No, I'm sorry, 16B. Consist of 2 or more polypeptide subunits. Yeah, that's right. The forces that maintain the 3-dimensional structure of a protein is mainly 17B, covalent. The forces that maintain the 3-dimensional structure of a protein is mainly covalent. And the following type of interaction is mainly responsible for aggregation of proteins in dilute solutions. Which type? B in the sense hydrophobic interactions, mainly responsible for aggregation of proteins in dilute solutions. Hydrophobic interactions. And protein structure is conformed by weak bonds, the example of which is hydrophobic. A favorable charge-to-charge interaction between R group in an alpha helix is expected to occur when the interacting side chains are separated by 3-4 residues. And which one of the following is an example of a non-covalent interaction in protein? Which one? 21A. Salt bridge. That's a non-covalent interaction in proteins. Okay. Then What does a protein lose when it denatures? When it denatures, it loses its three-dimensional shape. Not its primary structure, its peptide bonds, its sequence of amino acids, just its three-dimensional structure. Then which one of the following is the least important factor as far as protein folding is concerned? Least important factor. 23D. D. Quaternary association. All others are important. Hydrophobic effect is very important. Hydrogen bonding is important. Electrostatic interaction is also important. But only the fourth one is not that much important. That's quaternary association. In the alpha helix, 24 24 A. Okay, A is the correct answer. A. In the sense P and Q are correct. The hydrogen bonds are roughly parallel to the axis of the helix. The R groups on the amino acid residues are found on the outside of the helix spiral. Then in how many ways can 8 cysteine residues in a protein form disulfide bonds? 25D. D. 28. When you boil an egg, you convert the albumin into a white solid mass. In chemical terms, you would say that 26B. The protein was denatured by heat. Yeah, that's right. And thermal denaturation of protein involves conformational change in the protein. There won't be any cleavage of the peptide bond. There won't be covalent modification of certain amino acids. Increase in isoelectric point, nothing will happen. Just conformational change in the protein will be taking place. Then DNA polymerase contains a lysine residue that is important for binding to DNA. Mutations were found that converted this lysine to either glutamate, glycine, valine, or arginine. Which mutation would be predicted to be the most and least harmful to the ability of an enzyme to bind to DNA? Most. 28D. D in the sense glutamate and arginine. Okay. And its statement about proteins is correct. 29 correct answer is found to be C. So examples of protein secondary structure include an alpha helix or a beta pleated sheets. That's obvious answer. All others are incorrect. Protein quaternary structure is determined solely by the primary amino acid sequence. That's not true. Protein sequence that span a lipid bilayer membrane contain a number of charged amino acids. That's also not true. And protein tertiary structure is the result of the interaction of two or more independent polypeptides. That's also wrong. Which one of the following statement about protein structure is correct? 30C. Globular proteins tend to fold into configurations that keep hydrophobic side chains in the interior of the molecule. Yeah, that's right. And water has a high dielectric constant value of 80 because of its presence in biological systems compared with low dielectric solvents like hydrocarbons. It should weaken electrostatic interactions but strengthen hydrophobic interactions. So that's all about today's lecture. Tomorrow we'll be continuing with other questions about this protein structure, globular and fibrous proteins in particular. So thank you.